So the 2013 circle question, two circles touch externally. So if they touch externally, then that means that the distance between their centres is the sum of the two radii. The other condition is if they touch internally, then the distance between the centres is the difference in the radii. So it's the big radius minus the small radius, and that will be the distance between the centres. So we're told that they touch externally, so that means that the distance, so just the sum of the two radii added together. So what's the equation of this circle? So it'll be x minus 3 squared plus y minus 2 squared equals 4. Now then when you square that out, so square the first, you'll get x squared. Then you'll have a y squared as well. The x coefficient, multiply the two of them and double it. The y coefficient, multiply the two of them and double it. Now then you'll have 9, and 4 is 13, and then take away 4, so 9 and 4, so that'll be minus 9 equals 0. Okay, so that's just from the circle formula in your tables. Now this circle here, minus a half the x coefficient and minus a half the y coefficient. And then the radius will be found by using this formula on page 19 of your table is g squared plus f squared minus c. Now g and f, another way of looking at the centre of the circle is to say that that's minus g and that's minus f. So g in this case will be minus 1. So if you substitute those values in, now it's a bit annoying the way it doesn't really leave you much room for work here. So minus 1 squared plus minus 1 squared. Minus 7 is plus 7. So put all that into your calculator and you'll get a radius of 3. Now find the coordinates of the point of intersection or the point of contact. Now the distance between them is 5. So this is 2/5 of the way along the point of contact because the radius of that is 2 and the radius of that is 3. So see there, the radius of C1 is 2 and the radius of C2 is 3. So what we're going to do here is we're just going to use a translation. So from minus 3, minus 2 to 1, 1. So if you go from minus 3 to 1, if you look at the change in the x coordinate, you've added 4. And if you look at the change in the y coordinate, you've added 3. Now the point of contact is 2/5 of the way along. And it'll be on that line between the two centres. So the change in the x coordinate is 4. So what's 2/5 of 4? Well, 2/5 of 4 is 1.6. And 2/5 of 3 is 1.2. So with a starting position of minus 3, minus 2, go up 1.6 on the x-axis and go up 1.2 on the y-axis, and that's your point of contact. So just using a translation. Hence or otherwise, find the equation of the common tangent. The common tangent is this line here. It's common. It touches each circle exactly once. That's what a tangent does. Hence or otherwise, find the equation of the tangent t, common to both of them. So what we're just going to do is we're just going to subtract the two circles. So x squared plus y squared plus 6x plus 4y minus 9 equals 0, and just subtract the other circle. Now you're going to subtract all of it, so put the minus sign outside the bracket, so the minus sign will change the sign of everything inside the bracket now. So x squared minus x squared, y squared minus y squared, 6x minus 2x, that'll be 8x. 4y minus 2y will be 6y, and minus 9 minus 7 Sorry, that should actually be up here, beg your pardon, that should actually be plus 9, I think, is it? Let me see, 9, yeah, it should actually be plus 9. Didn't affect anything else in the question, though, thankfully. So that should be plus 9. 9 minus 7y, so that'll be 9 plus 7, that'll be 16 equals 0. Now we could simplify that down a bit. 4x plus 3y plus 8 equals 0.